Hi Year 9s, and welcome to this video where we will be reviewing some common mistakes on the Term 1 CAT. What I'll be doing in this video is I'll pick out a few techniques or topics that weren't done so well by the class. I'll run through some questions, and hopefully this will bring Term 1 to a nice close, tying up some loose ends and hopefully clarifying a few things for you. Now, before I proceed with this video, I want you to know that I will upload the notes in this video to Compass, so you don't need to worry about writing everything down now. You can if you want, but my advice is just watch the video, try to take as much in as you can, and if you want to write stuff in your bound reference, you can do this at a later time. The other thing I want to say is that if you want to watch this video again, you can. The link to this video will be provided in the lesson plan on Compass. So without further ado, let's get into the review. So I'll start with some general feedback. By this point, you should have the CAT in front of you. And here I've identified some of the things that were done well by the class. So I gave lots of ticks for these things. So the first thing that was done well was adding fractions with the same denominator. And this was the first two parts of question 1. The next thing that was done really well was finding the lowest common multiple. This is where we had the 5-minute and 8-minute baker. And you wanted to find when the two bakers would finish a job at the same time. Rounding was also done really well. So in question 4, you rounded to the nearest whole number, and you also rounded to the nearest tenth. You did really well when increasing decimals by a fraction. You did well by adding decimals. And the last part, part 3, where you worked with indices, that question was also done quite well by the class as well. So well done, and just want to commend the work that some of you did in preparing for the CAT. It's clear that some of you took the revision questions seriously and made an effort to revise before sitting the assessment. So what do we need to work on? What can we improve on? Well, I've listed a few things here. So the first thing that we'll look at in this video is what to do when we have mixed numbers. Fractions have always been challenging for generations of students, and so mixed numbers is really sort of the last layer on top. So if you can do everything, mixed numbers is like your last challenge, essentially. Related to fractions is the notion of dividing fractions. I think this area needs further work, and it's actually quite simple. You probably just need a bit more practice. Question 3 wasn't done particularly well, and I think that's because it wasn't obvious that what you needed to do was look for the highest common factor. So this was the donut question with the cinnamon and the sprinkles. If you recognized that this question required you to find the highest common factor, then it was pretty straightforward to do. But I think we didn't make it obvious enough, and so nobody looked for it. The word factor seems to confuse students as well. And I remember putting some revision questions about this. So I think what happened here was we just weren't familiar enough with the language of the word factor, and we needed some more practice. So we'll have an opportunity to do that in this video. And lastly, what I want to say is when you're learning fractions, it's quite easy to confuse addition and multiplication. I want you to remember that these two processes are very different with fractions, and your approach is not going to be the same. Multiplication is easier. You just multiply the top numbers and the bottom numbers together. Done. If you're adding, usually you need to check if your denominators are the same before adding the numerators. I know that was a lot, so let's take it one step at a time with a few examples for each dot point. So let's begin with mixed numbers. And specifically what I want to do here is convert a mixed number to an improper fraction. And remember, an improper fraction just means that the numerator, that is the top number, is larger than the denominator, that is the bottom number. So let's start with the first example. I've given you a mixed number, 2 3/5, and what I want to do is convert it to some fraction out of 5, and I just want one number on top. That number is going to be bigger than 5. How do we work this out? Well, what we need to recognize is 2 wholes is the same as 10/5. And the way that we get the number 10 is to do 2 times 5. So the numbers that I'm multiplying are the whole number part and the denominator. 2 times 5 gives me 10, and then I add the numerator. 10 plus 3 gives me 13. And so 2 3/5 is the same as 13/5, or 13 on 5. That's all you've got to do. So I'll quickly do the next 2 examples. Next, we're looking at 4 5/6. Our first step is to multiply the whole number part by the denominator. So we'll do 4 times 6, and that gives us 24. Then we add the numerator, which is 5. So we'll do 24 plus 5, and that gives me 29. So 4 5/6 is the same as 29 on 6. Finally, 7 times 10 gives me 70, and 70 plus 3 gives me 73. So 7 3/10 is just the same as 73 on 10. If I were to summarize what we did here, the first step is to multiply the whole number by the denominator. Next, we add the numerator. And finally, we'll say that the result is the numerator of the improper fraction. As I said at the beginning, you'll be able to look at these notes and watch this video again should you wish to do so. Just see Compass. Alright, now we went from mixed numbers to improper fractions on the last page. Now what we want to do is go the other way, and this is not as easy to do. Suppose I gave you the fraction 15 on 4. What I want to do is say that this is the same as some whole number plus some fraction out of 4, where that numerator is less than 4. And the question is, what numbers should we put in these boxes? It's actually not very obvious. So what we need to do is start by considering the multiples of the denominator, which is 4. So just from memory, I know that 4 times 3 is 12, and 4 times 4 is 16. What I'm doing is I'm counting up by 4s until I find 2 numbers which enclose 15. So I found 2 numbers, 12 and 16, and 15 is between those two numbers. And so that tells me that the large whole number is going to be 3. Because 3 wholes gets me to 12 quarters. And now all I need to do is take 15, which is the numerator of my improper fraction, and take away 12, which was 3 wholes. That is, 3 wholes gave me 12 quarters, and 15 minus 12 gives me 3. So 15 on 4 is the same as 3 and 3 quarters. If it helps, what I'll do is I'll write on the side that 12 on 4 is 3, which means 13 on 4 is 3 1/4. 14 on 4 is 3 2/4, and 15 on 4 is 3 3/4, and 16 on 4 is 4. Since the number 15 was between 12 and 16, I know that the number is going to be between 3 and 4. And that's why the whole number part is 3. I hope that by writing all of that out, it's helped you to see what's happening. Okay, let's do another one. This time, we have the fraction 22 divided by 7. So again, we'll start by writing down some numbers which are multiples of 7. If we count up by 7, we have 7, 14, 21, which is smaller than 22, and 28, which is larger than 22. So this tells me the whole number part is again going to be 3. And now all I need to do is take 22 minus 21, and that gives me 1. That is 1/7. Now, if it helps, I'll write it down here. What we're saying is 21 on 7 is 3 wholes. And therefore, 22 on 7 is just the same as 3 plus another 7th. Okay, last one. I'll do this a bit more quickly. 71 on 8. What I'll do is I'll count up by 8, and eventually I'll find that 8 times 8 is 64, and 8 times 9 is 72. I want the number that is closest to 71, which is smaller. So here I have to multiply by the number 8, which means the whole number part of the mixed number is going to be 8. Next, I take my numerator, 71, and take away the number that I calculated previously, which was 64. And 71 minus 64 is 7. So 71 on 8 is the same as 8 and 7/8. One final comment I want to make before continuing is that when you are converting an improper fraction to a mixed number, when you first do this, notice that the denominator is the same. The only time when your denominator will be different is if a simplification happens. So for example, just really quickly, I could do another one and say 72 on 8 is the same. Sorry, I'll do 70. 70 on 8 is the same as 8 and 6/8. And 6 on 8 is the same as 3 and 4. The only reason why I've decreased the denominator now is because of simplification. If you don't have this happening, then the denominators should be the same when you're doing this conversion. If the denominators are different, that means you've done something wrong. Okay, so that's mixed numbers. Let us continue. The next thing I want to talk about, by way of review, is dividing fractions. I mentioned this in class on Tuesday. This is a summary or a mnemonic that is taught to many students in year 7 and 8, and it's called Stay, Change, Flip. 3 simple steps to divide 2 fractions. So what do we need to do? Well, the first fraction stays the same. So by first, I mean the fraction on the left. And if I want to divide by the second fraction, what I need to do is change the division sign to a multiplication sign, and then flip the second fraction, which is on the right. So that means the numerator and the denominator have swapped. So I'll just do a couple of examples of this. So we'll begin with 2/3 divided by 4/5. Let's go through the list. First, the fraction on the left is going to stay the same. Second, the division symbol is going to change to a multiplication symbol. Finally, the fraction on the right is going to be flipped, upside down. And now we need to recall how we multiply fractions together. There are many ways to do this. The simplest way, but not always the quickest way, is to multiply the numerators together and the denominators together. And that gives me 10 on 12. And because there is a common factor of 2, that is to say 2 goes into both 10 and 12, I can rewrite this as 5 on 6. But if you answered this, you've demonstrated your understanding of how to divide fractions, and to go from 10 on 12 to 5 on 6 is a separate skill of simplifying fractions. All right. What about the one on the right? This is the kind of question that was given on the assessment. The trick here is to start by converting to an improper fraction. So we just did this previously. 3 times 5 gives me 15. 15 plus 2 gives me 17. 1 times 3 gives me 3. 3 plus 2 gives me 5. So the second fraction can be rewritten as 5 on 3. Now, the first fraction stays the same. The second fraction is flipped, and the division symbol is changed to a multiplication symbol. And if you do this calculation, you'll get that. I don't expect you to know that 17 times 3 is 51. But you can work it out because it's the same as 30 plus 21. And if you wanted to, you could convert this to a mixed number. You don't have to. I would accept this. All right, let's continue. That's dividing fractions. The next thing I want to look at is how we increase and decrease a number by a factor. The word factor seems to elude most people on the CAT, and for many of you, I actually circled this word on your CAT. It doesn't mean we take away 1/3 as a fraction. What we need to do is first calculate 1/3 of the quantity given that we're starting with, and then add or subtract. So let's do a few examples. First, let's decrease 240, or 2.4, by a factor of 1/3. So we first need to do 1/3 of 2.4. And if you do this calculation, you can do it on a calculator, you get 0.8. You should recognize that 8 times 3 is 24. So 0.8 times 3 is 2.4, and therefore 1/3 of 2.4 is 0.8. Now, the question asks us to decrease 2.4 by a factor of 1/3. The word decrease means to go down. So we'll start at 2.4, and we will decrease or subtract by 0.8. And that gives us 1.6. Now, it's interesting. The majority of the class was able to do it when the answer was when the starting point was a decimal. But once we changed it to a fraction, we got a bit lost. I want you to see that it's actually exactly the same calculation. So 1 4/5 is the same as 9/5, converting to an improper fraction. And if you do this calculation, you'll get 9 on 15, and we can divide both the top and the bottom by 3 because there is a common factor of 3, giving us 3/5. So now what we want to do is take this number 3/5 and add it back to 1 4/5. So 1 4/5 plus 3/5. There's a number of ways to do this calculation. I'll do it the long way, just to keep it simple. I'll convert 1 4/5 to an improper fraction, 9 on 5. 9 plus 3 gives me 12. And then I'll convert back to a mixed number. Just because the question was given with a mixed number to start with, so it makes sense to give an answer in the same form. Notice here that I did not add 1/3. I added 3/5 because 3/5 was 1/3 of 9 on 5. Okay, last one. In this question, we're asked to increase 3 5/6 by a factor of 1 2/3. Again, there was a question like this on the CAT. Same approach. Mixed numbers are a bit annoying to deal with, so perhaps changing to an improper fraction will help us. So let's do that. 3 times 6 gives me 18. 18 plus 5 gives me 23. 1 2/3 is the same as 5 on 3. You can tell that this is going to get a bit messy, but that's okay. You have calculators. This gives us 115 on 18. And I'm not going to commit to converting to a mixed number just yet because I need to add this back to 3 5/6. So 3 5/6 is the same as 23 on 6. So if I add 115 on 18, it's pretty large, isn't it, these numbers? So normally you would use a calculator. To get from 6 to 18, I just need to multiply by 3. I don't need to change the second fraction because 18 is divisible by 6, so I only need to change the first fraction. 23 times 3 gives me 69. And now I will do 115 plus 69, and that gives me 184 on 18. And that is the same as 10 and 4/18 because 10 times 18 is 180. And because 4 and 18 have a common factor of 2, I can write this as 10 and 2/9, since 4 divided by 2 gives me 2, and 18 divided by 2 gives me 9. The mechanics of this calculation were complicated, but the process was the same. Notice that there were 2 steps to each calculation. First, we took a fraction of our starting number, and then I took the result and I added or subtracted that. Okay, I think we're nearly there. 3 more pages. and then we're done. So this is related to question 3, which was the donut question. If you were able to find the highest common factor in that question, and it was 15, then you were able to locate the quantity of sprinkles and cinnamon needed in that question. Here, I just want to focus on the process of finding the highest common factor. So how do we do this? Suppose, by way of example, that I wanted to find the highest common factor of 24 and 40. Remember, a factor is a number which divides another number with no remainder. So for 24, I need to look for ways to make the number 24 through multiplication with whole numbers. So how can I make the number 24 with multiplication? Well, first I could do 1 times 24. I could also do 2 times 12, 3 times 8, and 4 times 6. Now, if I say I can make 24 using 6 times 4, that's true, but I've kind of already got that from 4 times 6. So at this stage, I can stop because I've found all the factors. It's 1, 2, 3, 4, 6, 8, 12, 24. Okay, and now we'll do the same thing for the number 40. So how can I make the number 40 with multiplication? Well, I can do 1 times 40, 2 times 20, 4 times 10, and 5 times 8. There are no other ways. So the factors of 40 are going to be 1, 2, 4, 5, 8, 10, 20, and 40. Now, for the highest common factor, I'm looking for the number which is the largest that appears in both lists of factors. And the largest such number here is the number 8. There is no number larger than 8 which appears in both lists. And therefore, the highest common factor is going to be 8. Okay, I'll quickly do a second example. To make the number 21, I can do 1 times 21 or 3 times 7. And that's actually it. There's nothing else I can do. For the number 36, there's lots of ways to do this. I could do 1 times 36, and I could do 2 times 18. Now, that might not be obvious because you might not know your 18 times tables. But the reason why we know that 36 has a factor of 2 is because 36 is an even number. That is, 36 ends in the number 2, which means 2 has to be a factor. Then we have 3 times 12, 4 times 9, and 6 times 6. Even though the number 6 appears twice here, we'll just say that 6 counts as a factor sort of once. If I write the number 6 twice in my list, it doesn't give me any new information. So the factors of 21 are 1, 3, 7, and 21, and the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. And the largest number, which appears in both lists, is, surprisingly, just the number 3, because 7 and 21 aren't factors of 36, which means the highest common factor of 21 and 36 is 3. Now, suppose you wanted to do this with larger numbers, you would actually want to use a different method to what I've used here, because for larger numbers, the lists get very long. But you don't need to worry about that at Year 9 level. If you just write out all the possibilities, that will be enough. if you go on and take the advanced maths course, which is called Maths Methods, you'll learn a way to do this, which is more efficient, and that's called the prime decomposition. But I'll leave that for now, and if you get to see that in a couple of years, you'll see what I'm talking about. Okay, let's finish. 2 more examples. So I want to finish by just reviewing how we add fractions. I think this is perhaps the hardest part of fractions below dealing with mixed numbers. And that's because fractions are difficult to add when the denominators are different. When you're looking at this, you can't just add the denominators together to get 4 on 20. That's wrong. So what we need to do is start by converting the 2 fractions so that they have the same denominator. So I'm going to start by doing this sort of inefficiently. There is a number that there's a number that is divisible by both 8 and 12, which is quite small. But it might not be obvious to you unless you know your times tables really well. So let's suppose that we didn't know our times tables really well. We can still get an answer to this question by taking the following approach. What we want to do is find our new denominator by taking the 2 denominators and multiplying them together. I will take this second denominator and multiply both the top and the bottom of the first fraction by it. And then I'll take the first denominator and multiply the numerator and denominator of the second fraction by it. And now I want you to observe what happens. If we do this, we get 36 on 96 plus 8 on 96. And can you see what's happened? Now the denominators are the same. I've got 96 in the bottom of both fractions, which means now I can add the numerators. And 36 divided by 8 gives me 44. And if you're seeing what I'm seeing, both numbers in the top and the bottom can be divided by a common factor, which is 4. You might start with 2 and then do it again. But if we divide both the top and the bottom by 4, or use a calculator, because a calculator can simplify fractions, we'll get 11 on 24. Alright, that's the first method. This method is always going to work, and it's your fallback if you're rusty with your times tables or you're just not sure what to do. Now, the other approach to adding 2 fractions is to use what's called finding the lowest common multiple, or the LCM. So what I'm looking for is the smallest number, which is a multiple of both 8 and 12. So I could start by listing out the first few multiples of 8 as follows. And the multiples of 12. Those are 12, 24, 36, 48, and 60. And what we're looking for is the lowest, or the smallest number, which appears in both lists. And in this case, the smallest number is 24. So that means the LCM of 8 and 12 is 24. And so to get from 8 to 24, what I need to do is multiply by 3. Similarly, to get from 12 to 24, what I need to do is multiply by 2. So let's go ahead and do that. 3 times 3 gives me 9, and 1 times 2 gives me 2. Notice again, I have the same denominator, 24, but the number is smaller. And smaller numbers are easier to deal with. So that's the advantage of using the second method, where we find the lowest common multiple, or the LCM. However, it's time consuming. You have to do this work to get that number. If you're not sure how to do this approach, then you go back to method 1. The price you pay for method 1 is your numbers get large, and you may need to do some simplification to get to your final answer. But no matter which method you use, if you've done it correctly, you should eventually get the same answer. In this case, it's 11 on 24. In my experience as a maths teacher, I found that students don't like it when I show them multiple ways of doing the same question. And I think that's because we want life to be simple. We want there to be just one way. It's less to remember. My encouragement to you is that if you find it confusing that I've shown you 2 different ways to do the same question, is that by knowing more than one way, it deepens your understanding of the maths. And sometimes it's better to know more than one way, because one way might be quicker or easier than the other way. If you only know one way, you could end up wasting a lot of time on a method that's really inefficient. Okay, last example. Again, we're going to add 2 fractions with different denominators, and we're going to have 2 mixed numbers. So in my opinion, this is perhaps the hardest sort of fraction question I can give to a student. So what should we do? Well, I think in this instance, what we want to do is convert both fractions to improper fractions first. So this is the same as 8 on 5 plus 17 on 6. I got the number 17 by taking 2 times 6, which gives me 12, and 12 plus 5 gives me 17. Now what I want to do is convert to a common denominator. In this case, I don't need to find the LCM, because if I multiply the 2 numbers together, I automatically get the LCM. And the reason for that is 5 is a prime number, and the decomposition of 6 is 2 times 3, and those 2 numbers are also prime numbers. So we don't need to worry about the LCM strategy. We can just go with method 1 here, and that gets us the solution as quickly as possible. So let's convert the fractions. 8 times 6 is 48. And 17 times 5, this is pretty large. It's 85. 10 times 5 is 50. 7 times 5 is 35. 50 plus 35 gives me 85. Okay, and now I need to add 48 and 85. 40 plus 80 is 120. 8 plus 5 is 13. 120 plus 13 is 133. 30 times 4 is 120. 133 minus 120 is 13. So this is the same as 4 and 13 on 30. Now, I want to show you another way to do this question. And this approach is going to make the numbers smaller. So here's the idea. What I'm going to do is keep the whole numbers separate, like so. So 1 plus 2 gives me 3, and now I will do the conversions. And you can see that the numbers are now smaller. (18 plus 25 gives me 43. And 43 minus 30 gives me 1 plus 13 30ths. And now I can group the whole numbers together. Giving me the same answer. Now, you don't have to write all these lines. But this is the sort of reasoning sitting behind how we could get from here to here by splitting the whole number parts into 1 and 2, and then combining everything at the end. The advantage of this approach is my numbers were smaller. 18 and 25 versus 48 and 85. I'm sure you'd agree that smaller numbers are easier to work with. So on that note, congratulations on finishing the content for term 1. If you would like some further support with fractions, there's a lot of information available on the internet. Just search fractions and things will come up. So if you think you will need this in the future, because you're taking a math pathway, I encourage you to get as much practice as you can with fractions, because it does sit behind a lot of the maths in years 10, 11, and 12. And you'll find it easier to get through life and get through mathematical situations if you are confident with basic fraction work. So I'll leave the video there, and I want to thank you for your attention and wish you well in your future work. Take care.